All right, so if you are watching this video, that means you have started problem 12-1 in your groups. You might have checked it with each other, but you're coming back to see if you can get more explanation on this problem. And also I will talk about 12-2. So for the first problem, you're solving equations, and our goal is to try to figure out whether the equation is always true, sometimes true, or never true. And this is what I have so far from my work. It's the A, B, C, D. Now I want to talk a little bit more about D. You can pause the video to look at all this work compared to yours, but again, I'm going to talk more about D. For D to solve this equation, what I did is I distributed the factors in front of each quantity, and I got this as my next step of my equation. And what I'm actually going to do to solve it is multiply both sides by 12. Because I got fraction with denominator 3 and denominator 4, so to get rid of them all together, I'm going to multiply both sides by the multiple of 3 and 4, which is 12. And you're going to end up with 12 times 2, which is 24 divided by 3. That'll end up with 8 and x. 12 times -6, -72. And then here, 12 divided by 4 is 3, and then times 6x, 18x. The same thing, 12 divided by 4, 3, times 15, 45. And then I solve that equation, subtracting 18x both sides, adding 72 both sides. We get this, and then you divide by -10. Here is your x value. That's how you can solve that equation. Now, let's determine whether the equations are always, sometimes, or never true. First one, part A. You have left side and the right side exactly the same. And that is an example of distributive property. If you multiply a constant to the factors, then you get 5x minus 35. This is always true. Left side of the equation and the right side will always be the same. B, this equation will only be true when x value is plus or -5. So then this is sometimes true. Sometimes true only for this particular x value. C, -2 and -7 will never be equal to each other, which means this equation will never be true. D, similar to B, we found an x value, meaning this equation will only be true for that particular value of x. Therefore, we can say that the equation is sometimes true. And why does all of this always, sometimes, never true matter? What's the importance of it? Well, A was the only one that is always true. And when an equation or something is always true, in math, we say that that is actually a mathematical property, just like this one. This was an example of a distributive property which will always work, meaning it will always be true, and we can use that in other problems as well. So then in 12-2, now you're given equations with trigonometry like sine, cosine, or even tangent. You could be given a tangent. So then for these equations, we're going to have to decide whether this is always, sometimes, or never true. And it says you can justify with as many representations as you can, meaning you can actually use graphs to determine whether it is always, sometimes, or never true. So let's look at an example. Sine of x equals 1/2. Okay, that's an example that is similar to what we've been doing in our warm-ups. So sine of x equals 1/2. If we're solving that equation, we're looking for an angle that has a sine value of 1/2. So we think of it as a unit circle. What are the angles that have sine value of 1/2? Sine values are y coordinates, and we want positive 1/2. So that's going to be pi over 6, which has a coordinate over 3/2, 1/2. It has a sine value of positive 1/2. And then you would have another coordinate in quadrant 2, which is 5 pi over 6. So then your answer for this equation is that x values are pi over 6 and 5 pi over 6, meaning This is sometimes true. This equation will only be true, meaning sine of x will be equal to positive 1/2 only if x equals pi over 6 or 5 pi over 6. Sometimes true. Okay. Looking at part B. Now the next one. Cosine of x equals 2. Well, think of a unit circle. Is there any angle in unit circle that has an x coordinate of 2? And this is a unit circle, right? Unit circles have radius of 1, meaning the highest value you can have is 1. Okay, therefore, this is going to be impossible. We can't solve it. There is no solution. So we're going to say this is never true. And the reason for that is because it's a unit circle, which has a radius of 1, sine or cosine value cannot be greater than 1. You could have 1, 0 or 0, -1. It can only go up to -1 or 1, but it can't be over that value, right? All right, so far we talked about A and B. Now, I do want you to solve the rest of these equations to determine whether this is sometimes, always, or never true. But I'm going to talk about a few more. And the ones I want to talk about are C, D, and F, because we haven't really seen equations like that before. And instead of solving those equations, we're going to actually look at graphs of those together. So we're going to move on to Desmos. We're going to start with C, go to D, and H. So make sure you are looking at these equations, or you have that written down, or you're looking at your handout, okay? All right, so we're looking at part C together right now. That's the first one we're going to look at. That's where we're trying to see if sine of x is equal to cosine of pi over 2 minus x. And what I'm going to do is I'm going to actually graph sine of x, which is the part of the equation on the left, and I'm going to graph cosine of pi over 2 minus x. I do have this Desmos linked on our Canvas webpage, so you can actually do it yourself as well. But let's see, sine of x, that's what the graph looks like. That's the graph of sine of x. Now here's what's going to happen. I'm going to click on cosine of pi over 2 minus x, and voila. It's just changed the color. Sine of x is red, cosine of pi over 2 minus x is green, and they are exactly the same. That's because, remember, we talked about this where sine of x and cosine of x, they are actually very, very similar. They're both very cyclic curves, right? Curves going on forever. And in this case, if you shift a cosine graph, okay, so here's a regular cosine graph. If you shift that cosine graph, which is the blue one, to the right pi over 2, then you actually will have the green one. And that means sine is actually cosine graph shifted over by pi over 2 radians. It's going to be the exact same graph. So C is always true. Okay, now let's look at D. So you're going to have sine of x, and then I'm going to graph sine of pi over 2 minus x. This one. Now it's a purple one. You got a sine graph, and you got sine of pi over 2 minus x. This time, they're not exactly the same. However, they do have some intersection points, right? Sometimes they do have the same values at pi over 4 radians, and they do have the same value at 9 pi over 4 radians, or 5 pi over 4, right? This is where they intersect. So they're sometimes true, sometimes they do have the same solutions, but not always, because they're not exactly the same. Okay, so D is sometimes. Then H, this is a cosine graph, right? Cosine is high, mid, low, mid, high. So this is your cosine graph. And then I'm going to make it equal to see what it would look like with sine of pi over 2 minus x. And again, this one is exactly the same. So it's kind of reversed from the part C. Now, cosine graph is exactly the same as a sine graph shifted by pi over 2 radians. Cosine graph is equivalent to a sine graph shifted over by pi over 2 radians. They are exactly the same, so part H is also always true. Okay, so we did A, B, C, D, H together, and I'm going to leave it up to you to finish off E, F, G. But if you ever want to come back and look at these graphs, I will have those Desmos links posted on Canvas, so you have access to it, okay? And also, I will have those graphs together on my handout, because I do have both sine of x and cosine of pi over 2 minus x for part C. If you're looking at the graph together, you can see that they are exactly the same. Whereas D, sine of x, and sine of pi over 2 minus x, they're not the same. But they sometimes intersect. So they are sometimes true. And then H, which is the last one we looked at, this should be wrong graph actually, so I'm going to have to fix that. But cosine graph and sine of pi over 2 minus x, they were exactly the same. So that would be the example for that. Should be y equals cosine of x. This is actually a cosine graph, and this is a sine graph shifted over by pi over 2. And again, they are exactly the same. It's always. So if you have not finished E, F, and G, then I'm going to have you pause the video and work on those, and then you can come back to take some notes.